On part 2, we're going to take a look at Heron's formula and an application problem here. Now, Heron's formula is another way we can use to find area of a triangle if you are given all three sides. In other words, you don't have an angle, all three sides. In other words, it's going to be our SSS model. Okay, we talked the other day about the law of sines one. That's that 1/2 BC sine of angle A. But Heron's form just says if we're given all the sides. And that's what we're kind of given down here. We have triangle ABC and we're given all three sides of our triangle. So if I draw it out, it's kind of easy to see that. Here's A, B, and C, where A being 14, little b is 24, and C being 19. Now the formula is pretty simple. It's A equals this S, the square root of this S, times S minus A, times S minus B, times S minus C, where S is what we call the semi-perimeter. Semi meaning dividing in half. It's A plus B plus C divided by 2. And again, we call that the semi-perimeter. Okay? So, first thing we have to do is find S. And S is very simple. It just says add them all together and then divide by 2. Now, when you type all of that in your calculator, what you wind up with is 28.5. Be careful with the word of operations. You might want to put that in parentheses up top there. And then I just plug it in. To get my area, it's the square root of 28.5 times, we're going to take that 28.5 minus the first side, times that 28.5 minus the second side, and that 28.5 minus the second side. The third side. Type all that in your calculator. Now be careful how you type it in. Very important for us. Clear, second square root, 28.5 times, I'm just typing it exactly as it looks, 28.5 minus 14, 28.5 minus 24, and 28.5 minus 19. Now close it. That closes this one. I got to close it twice to get the entire thing. And that gives me 132.915. 132.915 units squared. It's a very easy formula to use. All right. Now the last thing we're going to do is take a look at this application. Okay. Now this application is not necessarily a law of cosines, and we'll kind of see why. Han Solo must fly his Millennium Falcon around a black hole. It's too dangerous. So here's Han Solo. He's flying. Whee, there he is. And he encounters this black hole. Okay? So instead of it going through the black hole, he turns at an angle 21 degrees. Next, what he does, after he reaches a certain point, he turns back around. And he intercepts his original flight path at an angle of 35 degrees, winding up 4 light years from when he left his original. So this distance right here is 4 light years across. How far did he have to fly to avoid the black hole? So if I set this up, here's A, B, and C. Well, what do we need to find? Well, I need to find his path. Well, his path, I'm going to outline that in red. He traveled from A to B, and he traveled from B to C. Well, what does he need? He needs little c and little a. So we need to find both A and C. It's not very hard to get, but let's take a look at what we're given. We are given angle, side, angle. Now, remember what we said earlier in part 1. For angle, side, angle, you don't have to use law of cosine because I can convert this. I can find this angle right here. I can get angle B. And that's easy to do. To get angle B, we take 180 minus 21 minus 35. And that gives me 124 degrees right there. So this is 124. So remember that's 180 minus the 21 minus 35, which is 124 degrees. Now what we have here, we have angle, angle, side. We now have angle, angle, side, which is our law of sines. And law of sines is a little bit easier than cosine. All right. Now, so when I set this up, if I want to find A now, start with something we know. We know the angle for 24, so we know the sine of 124 and its opposite side is 4. To get A, I take the sine of 21 and I divide that by little a. Cross multiply A sine of 124. That's going to equal, and if I cross multiply here, we take the sine of 21 times that by 4. We get 1.433. And I divide. 1.433. So if I take that 1.433 and I now divide that by the sine of 124, we get 1.729. So 1.729 light years. So that's how far he traveled here, 1.729 light years. And now to get B, same thing. I'm now going to use law of sines again. I take my sine of 124 over 4, set that equal to my sine of C, which I already know is 35 degrees, over little c. And I cross multiply. I get 4, and we're going to do it this way. C times the sine of 124 equals, and I cross multiply here, we get the sine of 35 times 4. And that's going to give me 2.294. And I divide 2.294. I divide that by the sine of 124. And we get C equals 2.767 light years. And there we have C, 2.767 light years. Now, we're not done, because what we're asking for is how far did Han Solo travel? So to get that question, how far, we have to add this together. Well, for part A, he traveled 101.729, and then for part C, he traveled 2.767. And we just add those together. Might help if you can see it. So I take part A, add that to part C. And that's going to give me the number there. So if I add those together, we take you can do this on your own, 1.729 plus the 2.767, and he traveled 4.496 light years. That's the total distance. So he had to travel an additional almost half a light year in order to avoid the black hole. All right, so finish that example, and we'll see more of these practice problems tomorrow in class. Bye-bye.